So today we're going to talk about finding complex solutions of quadratic equations, and we're going to answer the question, how can you find the complex solutions of any quadratic equation? So far the tools we've had is really we've been looking at, we did factoring and we did roots. So those are two ways to find solutions of quadratic equations. Now we're going to look at some that include complex numbers, okay? Our standard for mathematical practice is reason again. We're going to be talking about numbers and symbols and what they represent a lot today. And then we're going to be definitely manipulating equations in different ways and really dealing with how quantities relate to one another. All right, so we're going to start with our Explorer, and we're going to investigate real solutions of quadratic equations. So we're basically kind of investigating the math or the theorems that they're going to talk about later, okay, or the formulas they're going to talk about later. So what they want us to do in this first column is, this is the standard form ax squared plus bx plus c equals 0. And what they want us to do is they want us to get it, they basically want us to subtract c from both sides. So I'm going to put the c on the right side with all of these. So this first one's going to be 2x squared plus 4x equals -1. This one's going to be 2x squared plus 4x equals -2. And this one's going to be 2x squared plus 4x equals -3. Then what they want us to do here is they want us to basically set the left side of the equation, because these two things are equivalent, to equal to f of x. So basically the left side is a function. So f of x equals 2x squared plus 4x. F of x equals 2x squared plus 4x. F of x equals 2x squared plus 4x. Interesting. They're all the same. Okay. The only thing that differs, it looks like, is the c value. So basically they're saying that the other side is going to be the second function, a function g of x. So g of x equals -1. G of x equals -2. And g of x equals -3. All right, so now they're saying the graph of 2x squared plus 4x is shown. They want us to graph each g of x and complete the table. Okay, so I'm going to start with this g of x equals -1. Remember, it's going to be a horizontal line through -1. And it wants us to tell the number of real solutions. Well, that's the places where they intersect. And it looks like it intersects 1 or 2 times there. So there's 2 real solutions. Find my pen and do a different color. All right, so this one here, -2, when I go through -2, it looks like it crosses 1 time. So there's 1 real solution. And then now I'm going to go through -3. And it doesn't cross the equation anywhere, so there are no real solutions. There could be imaginary solutions, but there's no real solutions to that. All right, so they want us to basically repeat the steps that we did here, in the same steps we did in part A, and verify. Notice this one's opening down instead of up. So that way we're kind of generalizing it for no matter what direction the function opens. So I'm going to start by subtracting c from both sides. So you've got -2x squared plus 4x. Instead of subtracting, we're actually going to add that 1 over, so equals 1. -2x squared plus 4x equals, we add the 2. And -2x squared plus 4x, go ahead and add the 3 to both sides. Then we're going to set each one of these equal to f. So f of x equals -2x squared plus 4x. We have that same thing 3 times. All right, and then we're going to set each one of them, the g of x equal to the c value, which is 1. And you're going to ignore the negative because they ended up being positive. So that's just stating that it was the right side of the equation. So g of x equals 1, g of x equals 2, and g of x equals 3. And now we're going to go ahead and graph those and see how many real solutions there are. So I'm going to start by graphing this one here. So through 1, and it looks like there are 2 real solutions. I'm going to graph through the 2. Looks like it touches 1 time, so there's 1 real solution. And then through the 3, It doesn't touch at all, so there are no real solutions, but possibly imaginary solutions. All right, so we're going to look back at steps A and B. Notice that the minimum value, okay, so let's review minimum really quick. So minimum, remember, is the lowest point on the graph. Okay, so they're talking, so all the steps A and B dealt with the minimum graph. All right, so notice in steps A and B, the minimum value of f of x in steps A and B is -2. So they're saying that the lowest number on this graph patch right here is the lowest y value is a -2. Complete the table by identifying how many real solutions the equation f of x equals g of x has for the given values. So they want us to look at right at -2. And I'm sorry, I'm having to flip back and forth. Let me use a different color again. I'll use the red. So right at -2 equal to -2, it has one real solution. When it is when g is less than -2, so let's go to less than -2. Whoops. Less than -2 would be down here. Less than -2 has no solutions. And I'm sorry, this is less than -2. I messed up my inequalities there. All right, and then when it is greater than -2, let's look at greater than -2. Whoops. So when I'm up here, I will always have, so no matter actually anything above there, I will always cross it twice. So I will have two real solutions in general there. All right, now looking at step C, notice that the maximum, so on the other graph, the maximum value was 2, so it's going to have us go through and identify those things as well. Complete the table by identifying how many real solutions the equation f of x equals g of x has for the given value. So exactly equal to 2. It crosses one time, so that has one real solution. When it's greater than 2, so when it's greater than 2, I have no solutions. It's not crossing at all. And when it's less than 2, when I'm less than 2, I always cross 2 times. So I would have 2 real solutions. So now it says you can generalize reflect 1 for f of x equals ax squared plus bx, where a is greater than 0. F of x equals g of x, where g of x equals -c, has real solutions when g of x is greater than or equal to the minimum value of f of x. The minimum value of f of x is, okay, so they got this whole huge mumbo jumbo here. So they're saying that the minimum is, when we evaluate the function for -b over 2a. So basically what they're going to do is they're going to take this, sorry, I touched the top. They're going to take that function right there, and they're going to substitute in -b over 2a into it. They don't give us. So that's what they're telling us to do right now. Okay. So then this is going to step us through that calculation here. Okay. So the first one, when we plug in, we're going to square it. So that's going to make the negative go away. We get b squared. 2 squared is 4. So that's where this number comes from. And a squared is a. Then they're going to multiply b times -b is -b squared all over 2a. Then to go for, so that was this step. And then to go to the next step, notice this a is going to cancel with one of those. So I get b squared over 4a, and then nothing happens to this, minus b squared over 2a. And then they tried to get it over a common denominator, so they're going to multiply these both by 2. So you get -2b squared over 4a, and now we can combine like terms. So b squared minus 2b squared is -b squared over 4a. So basically what this is saying here, okay, is when I plug into this function, f of x equals g of x has real solutions. And because this was a minimum, we know that the g of x function is greater than or equal to this value that we calculated. Then what they're going to do is they're going to substitute in -c for g of x into this function, okay? Then they're going to take this guy and add him to both sides. So they added him over to the other side. So now we're saying that it's greater than or equal to 0. And then in order to get this looking a little bit nicer so we don't have the fraction, they multiplied everything by 4a. So they multiplied that by 4a, this by 4a, and this by 4a, which cancels it here. It just gives us b squared. Then it's 4a minus 4ac greater than or equal to, and when you multiply it times 0, it's 0. So in other words, the equation ax squared plus bx plus c equals 0, where a is greater than 0, has real solutions when that formula is greater than or equal to 0. Okay? They basically want us to go through and do this exact same thing for reflect 2. Okay? The only thing that is truly going to change if we were to do that is the inequality sign. Okay? So basically what we've done here is we've proven how to tell if a solution is real or not. Okay? So I'm going to say you don't need to write this next part down. Okay? So just kind of watch. Okay? So if we were going to prove this for the other direction, okay, and I'm going to scribble over the top. This is horrible. Don't scribble over the top. Just watch, because I don't think you really need to write out this whole proof. Okay? So we're basically going to say we're going to switch it to less than 0. So the blue, what's in blue is going to be my new proof. Okay? It's going to say the same thing. Okay? We would plug in the exact same value here. Okay? And when we're going to change the word minimum to maximum value. So it's a max value anytime we see minimum. So the max value is still this. We plugged in the negative b, we're still going to come down to this. Okay. And then the difference here is going to be that the inequality is flipped the other direction, because it's a maximum, so it's going to be the g of x has to be less than or equal to negative b over 2a. So this is going to be flipped around. We're still going to see a negative c. We're going to flip this guy around. We're still going to see, we're still going to add the b squared over. We're still going to multiply through by 4a. This is flipped the other direction, so we're still going to get the b squared minus 4ac. So in other words, this equation where a is greater than 0 still, where no, a is less than 0, has real solutions when this is less than or equal to 0. So basically what we've said is that it doesn't matter whether a is greater than 0 or less than 0. This function right here tells us that when it has real solutions. Okay, so that part let's write down. Let's write that generalization down. So, oops, sorry, it got really big. So this is the whether a is greater than 0 or a is less than 0. B squared minus 4ac greater than or equal to 0 tells when ax squared plus bx plus c equals 0 has real solutions. Okay. All right, so now let's look at explain 1. I think I'm going to stop after explain 1 for today, and then we'll do explain 2 and 3 tomorrow. Okay. So this is completing the square. I looked at the way they're doing it, and they have all these insane, crazy steps. I think it's too much. I'm going to show you how to do it the Mrs. Ballard way. Okay. So we're probably going to want to write some stuff kind of in the left hand, scribble in the left hand some steps. I'm going to read through their stuff here, and then I'm going to kind of give you some shortcut steps that I usually do. So recall the completing the square for the expression. X squared plus bx requires adding b over 2 squared to it, resulting in the perfect square trinomial x squared plus bx plus b over 2 squared, which is a factor as x plus b over 2 squared. Don't forget that when x squared plus bx appears on one side of an equation, adding b over 2 squared requires adding b over 2 squared to the other side as well. Okay. So basically what you're going to do with completing the squares, the first thing I want, so right out here, you're going to divide by the leading coefficient. And that is in front of x squared. Are we going to probably see that today? No, but I don't want you to not to miss that step. Okay, the second thing is you're going to subtract the constant, which is typically the third term. Okay, from both sides. Add in plus blanks. Okay, that'll make sense when we do one. All right, then the third thing you're going to do is divide middle by 2. And the fourth thing you're going to do is square it. And then the fifth thing you're going to do is solve and simplify. Solve, simplify. All right. I'm going to ignore their steps, okay? So we're going to kind of write our work off to the left side, all right? Or off to the side. And we're going to see that we get the same answer that they do, probably in less steps, okay? So the first thing I'm going to do, okay, is I'm going to divide by the leading coefficient. So I'm dividing everything, including the 0. Go ahead and do that and write this in kind of over the top of their stuff, okay? So now I've got x squared plus 3x minus 2 equals 0. And they were not kind to us here and gave us a nasty odd number in the middle. So it's going to make it really ugly, okay? All right. Then I'm going to add or subtract whatever that third term or that constant is to both sides, leave a space, and then put in plus blank on both sides. Now I'm going to set up for what I call cheating factoring, because really what we're doing is trying to create a perfect square trinomial here so that it factors. Try to make that a little clearer, and I apologize, there are crying children in the background. All right, so I'm going to set up my cheating factoring. I set up the binomial square because what we're really doing is setting up one of these x plus 2 times x plus 2 is really, so x plus x squared plus 4x plus 4. So we're setting up one of these magic x's where when I have to multiply to 4 and add to 4, where when I get it factored, I get the same factor twice, okay? So I would probably rewrite that factor as something squared. I'd be really super cool about it. So that's what we're really trying to force and set up on that side, on the right side there. That you didn't need to write down. I was just kind of showing you where it came from since they gave us a really nasty one to start. Okay, so I'm going to divide this middle term by 2 is the next thing. And I'm just going to leave it the way it looks. It's ugly, leave it. Okay. Now, my hint is kind of right here. I'm going to square that term that I just created. So I'm going to write 9/4 and 9/4. We're really, really happy that we do not have to do a magic x on 9/4 and 3, because that's essentially what this is right here, okay? And that's not an x squared. Let me rewrite that line a little bit lower, because it looks like it's x squared. So it's really x plus 3/2 squared. Okay, now, downside is I need to make this into fourths, okay? I'm going to be really, really sloppy about this. I get lazy, okay? I'm going to make that into fourths. It's right now over 1. To make it over 4, I'd have to multiply by 4. So 2 times 4 is 8. So 8/4 plus 19/4, or plus 9/4 is 17/4. All right. Now I'm going to undo that squared. So I'm going to take the square. This is just like what we were doing last week. We're going to take the square root of both sides, put a plus minus out front. So x plus 3/2 equals plus or minus. 17 isn't a square number, so I'm going to leave it. This 4 is a square number, though, so divide it. Your square root of 4 is 2. And now I'm going to take this number and put it over on the other side. So x equals, I'm going to subtract it over 3 plus or minus square root of 17 over, sorry, it flipped. over 2. All right, notice they're over the same denominator, so I could rewrite it as negative 3 plus or minus square root of 17 over 2. In fact, I could have gone right to that step there, which is probably what I will do. So let's count. 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. Okay. Remember, the plus minus does take into account that it makes that there are actually 2 real solutions. So you might want, instead we had to state the number of solutions, because we didn't get any i's, we would write 2 real solutions. Okay, so you do not need to use their method. If you want to read through their crazy method, you can, but I prefer by, actually I take that back, I had 7 because I had to divide by 3. All right, so let's try it again. Notice there's nothing to divide by in this one, and they were a little bit nicer to us. They gave us a negative 2 in the middle, which is an even number, so that's a lot better. It won't be a fractional answer. All right, so the next step is I'm going to subtract the 7 from both sides and add plus blanks in. So we've got x squared, so find a place to squish it in here. Minus 2x plus blank equals negative 7 plus blank, because whatever I do to the left, I have to do to the right. All right, now we're going to set up that cheating factoring. So I do a parenthesis, basically I'm setting up for a binomial, a parentheses x, a parentheses, and a square. Then the rules say we're going to take the middle term and divide it by 2. So negative 2x divided by 2 is negative 1. My hint is right here. I've got to square the negative 1. Negative 1 squared is 1. Equals negative 7 plus 1 is negative 6. All right. Now we're going to go ahead and undo the square. So I'm going to take the square root of both sides, make sure you write plus or minus. Now, I can keep going on this because I know how to deal with a negative under a radical thanks to what we learned last week. So when we see a negative under a radical, remember we pluck our i's out, square root of 6. And I'm going to take the 1 and move it to the other side. So I'm going to add that over. So 1 plus or minus I square root of 6. Notice these are not real solutions. These are non-real solutions or imaginary solutions. So we'd write 2. Their terminology is non-real. You could also write imaginary. I don't think I spelled that right. Solutions. You pick how you want to say it. Again, look at, I did like 5 lines of work. They did a lot more. Okay. All right. How many complex solutions do the equations in part A and B have? Explain. All right. So complex solutions, remember, means real and imaginary. And notice both of them had 2 solutions. No matter what, they had 2 solutions because we always have that plus minus thing going on. So it had 2 complex solutions. So we'd say each had 2 complex solutions, and they'd say, and they said because complex numbers includes reals and imaginaries. So because complex, it's not writing, there we go. Complex numbers include real and imaginary. All right, so now we're going to try this on our own, okay? We need to remember we need to state real or non-real at the end. Okay, so this actually would be a really good time for you to pause the video and try number 5 and 6 on your own, and then come back and see if you've done them right, okay? Or try 5, then pause it again and try 6. All right, so I start with the leading coefficient. I didn't have one, so I basically divided by 1. I can skip that step. Excuse me. Now I'm going to take that third term, or my constant, and subtract it from both sides. So I've got x squared plus 8x equals negative 17, and you want to put in a plus blank on both sides because we're setting it up for our cheating factoring. All right, I'm going to set up my cheating factoring. All right, I'm going to divide this 8 by 2 is the next rule to complete the square. So I'm going to divide by 2, I get 4. And then to complete the square, the hint is I square that 4, so I get 16 to both sides. It's negative 17 and positive 16 is negative 1. So to undo the square, we take the square root of both sides. I put a plus minus on the right side. Get x plus 4 on the left. Plus or minus. See a negative under a radical sign, we know we pluck our eyes out. And the square root of 1 is 1. I can write it, but I really don't have to. Okay? And then I'm going to subtract the 4 to the other side. So negative 4 plus or minus I. So this case, we would have non-real solutions. So we've got 2 non-real or imaginary solutions. All right, solve the equation by completing the square again. Again, there's no leading coefficient. They're much nicer to us. They gave us the ugly one first, apparently. All right, so I'm going to add the 7 to both sides. So you've got x squared plus 10x, might as well put the plus blank in, equals 7 plus blank. Go ahead and set up your cheating factoring. So you're ready to have. The nice thing about setting this up, it gives us a placeholder for it to hold something so we don't forget the number. All right, so I'm going to divide both sides by 2. When I divide by 2, I get 5. Sorry, not divide both sides, divide the middle by 2. Then I'm going to go ahead and square the 5. I get 25 to both sides. 7 plus 25 is 32. I'm going to undo the square by taking the square root, put a plus minus in front. All right, we're going to review some of the other stuff we did last week. We got to do can and a can't do box. So I need the biggest square number that divides 32. And the biggest square number that would go in there. 4 goes in there, but it's not the biggest. 16 goes in there. That's bigger, and it goes in there twice. I'm going to do 2 things at once now. I'm going to subtract the 5 over. I'm going to take the square root of 16. Notice there's no i's, but there's still a plus minus, so we've got 2 real solutions on this one. Okay. Okay, so I think you're going to go ahead to finish off today to get your class points for today. I want you to go ahead and try number 10. And I think you can do 10 and 11. Sorry, I was trying to read through it there. So do 10 and 11. We'll save 12 for tomorrow. Okay?